Hi, welcome to a new session of Circuits and Networks. In today's class, we are going to see the problems which were asked in GATE 2026 under electronics paper. So here we are going to discuss only two problems. That is, one problem is based upon the network theorem concept and another problem is based on the two-port network concept. So we'll start with the first problem where we need to find out the transmission line parameters. So this figure is given where we have 1K, 1K and 1K and we need to find out the ABCD parameters. So for that, let us define the input and the output terminals of this given network as source voltage V1 supplying current I1 and V2 supplying I2 in this direction. So this is treated as input port and this is treated as output port. Now, the standard form of ABCD parameters are given by this equation, which is nothing but V1 is equal to AV2 minus BI2 and I1 is equal to CV2 minus DI2. So these are the two standard equations of transmission line parameters or ABCD parameters. Now we'll take the output port and we'll make it has to be open circuit. So when this becomes open circuit, I2 is nothing but it is 0 because the port is open circuited. So from equation 1 and 2 we can deduce equation 3 and 4. So you can see V1 is equal to AV2 and I1 is equal to CV2. And when you apply the output port as open circuit, the current is 0 in the output port but the voltage is measured across 1 kilo ohm. Now you apply KVL to this figure 1a. So we are going to get V1 is equal to 1 plus 1 2k I1. We'll read this one as equation 5 and V2 is a measurement of current in 1 kilo ohms where current I1 is flowing. So V2 is equal to 1k I1. So this becomes equation 6. Now you just compare the equations 3, 4 with 5 and 6. We are going to get the value of A, which is nothing but equal to V1 by V2. So 2k by 1k, I1 get cancelled, it becomes 2. The value of A is 2 and the value of C is nothing but I1 by V2. So you have to take I1 by V2. So that value will be equal to 1 by 1k, which is equal to 10 to the power of minus 3. So this is how we obtain A and C. A is known as the reverse voltage gain, whereas C is known as the admittance when output port is open circuited. Now what we going to see, we are going to apply the short over this port 2. So we are going to make here V2 equal to 0. So this is shorted like this and figure 1b is obtained from figure 1. Now we have the input terminals V1 I1 and substituting the value of V2 equal to 0 in equation 1 and 2 we are going to get V1 is equal to minus BI2. Let us treat as equation 7 and I1 is equal to minus DI2. Let us treat as equation 8. Now this 1k are in parallel, it becomes 500 ohms. So you have figure 1c where you can easily apply KVL and you can get the voltage V1 in terms of I1. And mind you, we need to also know what is the value for I2. For that we are going to apply current division rule. So we are going to take this equation 7 and 8 and when we apply KVL to figure 1c, we are going to get V1 is equal to 1500 I1. This 1k, that parallel is replaced by 500 and the series becomes 1500 I1. Now equation 9 is obtained. What about I2? I2 is the current which is flowing in 1k and these two are in parallel. So from the current division rule, I can get the value of I2 which is equal to minus I1 by 2 and I am treating this equation as 10. Now substitute equation 10 and equation 9. So we are going to get V1 is equal to 300 of minus I2. With this we can get the value of B from equation 7 which is nothing but V1 by minus I2 which is equal to 300. And from equation 10 we can get the value of D which is equal to I1 by minus I2 which is equal to 2. Now hence we got ABCD parameters which is 2, D is also 2, C is 10 power minus 3 and B is 3000. Now if at all we apply the condition for reciprocity and symmetry, they will match. That is A equal to D, that is 2 equal to 2, it's a condition for symmetry. And what about the reciprocity? AD minus BC should be equal to 1. So 4 minus 3000 multiplied with 10 power minus 3, it becomes 3. So 4 minus 3 it becomes 1. So the condition for reciprocity and symmetry is satisfied. Another way to solve this problem is to get the Z parameters. So Z parameters is given by Z11, Z12, Z21 and Z22, which is obtained here to be as 2K, 1K, 1K and 2K. You can simply open circuit and you can have the addition of these two. And 1K is the intermediate between these uh, two parameters, that is input side and output side. So that is how we got the value of Z parameters. Now once we got the Z parameters with the help of ABCD formula, means Z parameters in terms of ABCD parameters, we can get the value of ABCD as 2, 3000, 10 power minus 3 and 2. The same answer which we got using the actual approach. So this is how you should solve this kind of problem. Now in another problem, we need to find out the voltage V0. So V0 is obtained across 1 kilo and 1 kilo ohm, and the plus and minus sign is assigned in this direction. Now what we have to observe is that we have 1 milliamperes as one source, another as 6 volts. So we will take the help of superposition theorem and we'll make one source active at one time. In first step, I'm making 1 milliamperes as active and 6 volts as inactive. So this is how the circuits look like. Means you have a voltage source short circuited. Now you see this 1K and 1K both are in parallel, and denominator also 1K, 1K both are in parallel. So this becomes as 500, 500, which is in series, shown in figure 2b. Now you need to obtain the value of V0. In this series combination, 1 milliamperes is flowing. 500 plus 500 becomes 1000. So 1000 and 10 power minus 3, it becomes 1. So V0 will be equal to 1 volt. So this we are treating as equation 1. Now in the second step, we are making current source as inactive and 6 volts as active. So this is how the circuit changes to, which is given by figure 2c. Now we need to know the value of voltage across these two terminals. So for that, I'm taking a loop current I1 in clockwise direction and I2 in anti-clockwise direction as shown here, and I'll apply KVL. So in the upper loop, we are going to get I1 equal to 3 milliamperes. Similarly, in the lower loop, we are going to get I2 equal to 3 milliamperes. These currents, how does it flow across 1 kilo and 1 kilo? From bottom, it is flowing like this, plus and minus, because we are taking in anti-clockwise direction. From the top, it is flowing from upper to lower. So the net value of voltage, that is equal to 3 volts over upper side and minus 3 volts on the denominator sides. So the net voltage value here, it is 0. So from superposition theorem, you have to sum up the result 1 and result 2, which will give you the value of V0 is equal to 1 volt. So that's all for today's class. I hope you like this session. Please share among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.